The goal is to get code running in production. That's my mantra. As a consultant, when I go to work, if a feature is not in production and usable by the user, then it's not providing any value. So that's kind of how I think about my job when I go there every day. I want to get code to production. Currently, I am at the Norwegian Directorate for Education and Training in Norwegian Utdanningsdirektoratet. And our team there is around, it varies a bit between 15 and 30 people. And we are responsible for 3 rather big systems. And we have 3 kind of sub-teams that we go between. And we do continuous delivery. We deploy to production as often as we can, and as soon as we have something of value. Usually, we deploy only 2-3 times a week. Not because we can't do any more, but because, and I'll get back to that, we have a kind of gated deploy to production. We consider the master branch ready for production at any time. Some of you might know this as the GitHub flow. And that means we use feature toggles, we have peer reviews that are, we put a lot of trust in our colleagues in peer reviews, and we have short-lived feature branches. So our process kind of looks like this. You start by branching out from master, you write some code, add some commits, you open a peer review, it gets built to check if it actually compiles, tests are run, somebody from the team peer reviews it, says this is good. And then I want to point out these 2 kind of manual steps we have. If you have a database migration in your pull request, which means that when this change reaches production, if it migrates the database, you should mark it in the title with this hashtag DB migration. I'll get back to that. We also have the manual task of if your changes touches any task in our work item, in our work management system, you put the ID in the title. So it's easy to see, okay, this work task, these commits touch this work task. It doesn't matter if it's done or if it's in progress or anything. A work item, like a work management system that we use is Jira, Atlassian Jira, so that's an example, but it doesn't really matter in the scope of things here. It could be Trello, it could be whatever. But we put the Jira code of task we're working on in the title. And we merge in, and as soon as it's merged into master, master just builds itself, more thorough tests, and then it gets deployed to the dev or canary environment, whatever you want to call it. So the merge commit can look something like this, just to get it absolutely clear. We have a Jira task in there. We have the DB migration check. You can see that there is a build that has to pass, and it also says approved on the bottom line, which means someone on the team approved it. And I wrote a little text there that this DB migration hashtag, that could probably be automized with simple code analysis. So that's the way from developer to development environment, which we call dev. So it hits dev, and dev is deployed to tens of times a day. And we promote to the test environments when we want to do some more thorough testing. So we have 3 test environments, as you can see: test, test2, and integrations. Integrations is where we test other systems, test their integrations towards us, so it's a bit specialized for that. And in the other test environments, we have more automated tests and thorough tests for integrations we have. So when we are done and feel that we have a candidate for production, we put it in the Q&A environment. And the process we have is that when we put something in the Q&A environment, the customer wants their testers to approve the changes before we roll it out to production. And we're doing continuous delivery, so it might be only 3 small changes, but still they want to check that these 3 things are okay before it goes to production. The reason for this is that, of course, they are a government agency, and they care a lot about their reputation, and they care a lot about the services they provide to the rest of the sector, because they are doing that as a government agency for the government. So they want us to be thorough. They don't want things to break. So this is kind of a middle way between continuous delivery and a bit strict gated deploy with testing. So when the testers get their hand on a version in the Q&A environment, the first question is, what is the actual change here? What is the actual change that's going to go out into production that I need to look into? And at first, they started looking to Jira and seeing what in Jira has been put in the progress for testing, and they would use that. But of course, a lot of things that was going to production were feature toggled away, or there were code and architectural integration changes that didn't really touch any user stories or maybe tasks in Jira. So we wanted to automate this task and find out what are the changes and how can we give these changes to the testers so they can test and approve the version for production. So I like to think of it as this. We need to get the changes between environment X and environment Y for a given project or a given application that's going to go to production. So you can look at it like this. This is kind of a grid. So given Z and X, I can find out what version is in QA. Given Z and Y, I can find out which version is in production. And now I have the two versions of our two artifact versions. So now I just need to somewhere find what are the changes between them. So you can look a bit like this. Let's think of it as an application or a function that takes this input and gives us the changes in the other end. So what we need to determine given this input, because I wanted the input to be the environment name and not any IDs or anything. I wanted this function or app should be able to be called from a console app, from a web app, directly from the deployment service or application that we're using. So we need to somewhere to get the version in environment X. Now I'm thinking of how to implement this. We need to get the version in environment X. We need to get the version in environment Y. We need to go somewhere and get the changes between those two. Of course, those are in Git, so that's where we need to go somehow. And here comes in the kind of bonus where we have these DB migration hashtags, so we can find if there are any migrations in this deploy. And we also have some work items, so we can go to our work management system and fetch out some summaries, some statuses, and link everything up. So we get a smooth, nice list. So these are kind of the four things we're going to have to do inside our function. Go get the two versions, get the diff between them, parse them for migration and work items, and if there are any work items, doesn't have to be, we go and fetch them. In our case, these are the three systems involved. We use Octopus Deploy for deployments, we use TeamCity for builds, and Jira for our work management or project management. So this is great because Octopus Deploy, of course, knows which package. It's its job to know what package is in what environment. So I can just do two calls there. What is in X? What is in Y? I'll get those back. And then I can talk to the TeamCity API. They have a very good REST API, so I don't have to touch Git at all. They have a REST API over Git. Perfect. So I go there. I tell TeamCity what are the changes between these two versions. And then we parse them, and what do you know? Jira also has an API. So we're going to integrate with their API too, or we did, and we fetch stuff from there. So we basically need two things here to solve this problem. We need one tool or technology that is good at integrating fluently and easy with APIs and other systems, and we need somewhere to put this app or function when we're done without any hassle. And I guess by the name of the talk, by now you have understood what these two tools are. When we encountered this problem, we knew that F# was the right tool for the job because we had experience with F# from before. We'd written like some rule engines, domain-specific languages. We have an entire solution in F# that heavily uses type providers and all of the good stuff. But just to take a step back, we knew about what problems does F# solve that it actually solved for us. We ended up writing less code that gave us less errors. That's a given. But especially the last two in a very complicated domain where we're doing a lot of work and there is a lot of room for errors, we noticed that having option types and no null and having a super strong type system, if you catch Scott's talk, the last one yesterday in this room, you saw how powerful the type system is. By combining all this, we didn't get any loose cases or invalid states in our program. So we were able to solve a very complex domain in an easy way, which is where F# really shines. And of course, the biggest thing for us was maybe type providers, because we had a lot of different sources. We had SQL, we had JSON, we had CSV, and with type providers, we got all that easily into types without having to write user-generated code. We didn't have to do code generation, which is usually what you would do in C#. But user generation is not type providers. Type providers, you can think of them as code generation. It's just you don't have to think about code being generated into your project. If you have ever right-clicked and done an add service reference in a web project, you will know it generates a lot of code. And then if the API or service changes, you have to go in again, generate more code to get the changes. And type providers, they kind of takes that away from you. They do it for you. They are lazy loaded, so you can use them on big data sources without your app generating thousands of files, if there are thousands of types in this service. And there are type providers for everything. SQL, which I will show you, CSV, JSON, XML. There are even a Swagger type provider. So if you have an API that uses Swagger, you want to integrate with it from a client, you can just use the Swagger type provider and you will get all the types, all the functions you can call in this API, everything strongly typed and feedback directly in Visual Studio Code or Visual Studio or whatever. So we had a big project in C# where we had the data layer also in C# and we were using Dapper. I have to say this is a great piece of code for being C# at least, but this works and it's easy to read. You understand right away what it does. Of course, we have much worse queries than this in our application. This is just to point out a few potential errors. First of all, this can return null. So you have to remember to handle null. The compiler doesn't help you, so you have to have a null check somewhere here. Because first or default, it returns a result or null. So further up in stack, you need to have an if statement to check for a null value. Also notice that the SQL here is a string. So if I have a typo in the string, it will crash at runtime, not at compile time. So I'm going to have to write an integration test or something for this. Of course, most likely I'll do that anyway, but I'd rather typos were caught a bit earlier and I didn't have to run a lot of tests and to see that I have a typo. You can also see that the parameters we send in is an anonymous object. So it doesn't have any mapping to the actual parameter that is inside the SQL string. So if I have a typo there or it doesn't match, runtime error. And also, when we used Dapper, we ended up making a lot of types to map our database into our C# code that weren't domain objects. So we ended up writing code for the database to easily map everything in. Could write mappers, but this is that was the easiest way to get data into the C# app and then map them over to domain objects. Not the worst thing, but a bit annoying. So when we're making a new project, and we wanted to use the same stack that we have from before because we wanted new developers to be able to work on both applications without too much hassle. But we did one change, and that's that we decided to move from Dapper as the data layer to the F# data SQL client type provider. It's a TSQL type provider, so it's specific for SQL Server that we were using, and we only changed the data layer. So the rest of the application was still C#. Only the library just before hitting the database was F#. And this is in production now, so when the students take national tests this autumn, all 5th, 8th, and 9th graders have to take those tests that are mandatory. The results will be saved and loaded with F#. I think that's cool. And before you say, what the fuck, to this code, you might say, why is this better? It's just more code, and it looks almost exactly the same. Well, before I explain why it looks like this, I'm just going to say, if I were now to write something in there, you see the SQL is still a string, but if I was to write any typos there, I would get a red squiggly line under the whole string in Visual Studio right away, and it would tell me that this is not a table in the database, this is not a column. It actually checks against the schema of your database that you are writing valid SQL. And you get compile time errors if it doesn't match. And this is why it looked like it did. A lot of F# code, because we discovered that C#, F# interop is a bit of pain. But it's absolutely worth it. But it's something to be aware of. I don't want to come here and preach like, use F# as your data layer in your C# app. You should if you wanted the same things we wanted, but there are some things to note here. First of all, I just want to put out here with the async execute function we're calling is a strongly typed input to the SQL string I had before. So if I were to, in the string on the top here, if I was to change the where clause to use the ID instead, then the signature of the async execute here would change from, okay, I shouldn't ask for a string anymore, I should ask for a GUID. So it gets safety between the handwritten query and calling it from your code. As you can see, we new up object down here, mapping it from the magic type of the type provider to our domain type. I really regret us not writing our domain types in F#, because F# records are super easy to write, and if you use them from C#, they are idiomatic C# objects. You initiate everything to the constructor, and you don't have to, and you only have like getters. So it's kind of how we write C# codes. It's just so much less code, and it would look much nicer here, still the same from C#. We have somebody on the team made like a options utils that you see almost in the end here, because when we come to the C# side, it expects not an option like something or nothing. It expects something or null. And the last thing we had to do is map from the beautiful async API in F# over to the TPL and async await in C#. So most of this code that makes this a bit hard to read and a bit messy is because of this C#, F# interop. And yeah, code like this, writing code like this in F#, it keeps me awake at night. A lot of people ask me, like, how did the team handle F#? And I just want to say that I have amazing colleagues. They really are positive and they really see the benefits of it. So even if they are the ones much more than me working at this level and jumping between F# and C#, they really see the benefits, even though it's much harder to navigate in Visual Studio. Because if you try to shift F12, like go to definition on a, or go find usages on a F# function, it will start to decompile your C# code and show you where it is. It doesn't understand that I'm in the same solution. So the trick is just don't teach them the mutable keyword in F#, and they will learn. Okay. So now we kind of have our first tool in place to integrate with these systems. We already have knowledge with F#. We know that type providers are the best tool to use to do this, so we're going to use it. So now we need somewhere to put our function. And of course, function, you start thinking about, yeah, everyone's talking about serverless and functions as a service. So that sounds like exactly what we need. And as you probably have heard several times during this conference, like serverless is of course a bit misleading. There are still servers running your code. It's just that you don't have to think about these servers at all. That's a concept that you just throw out the window. You don't think about servers. So like scaling and patching and problems related to uptime, these are things you don't have to think about anymore when you run serverless code or run serverless. And you're outsourcing everything about the management to someone you trust. And usually that is, or if you're going to do this, you should use a public cloud provider like Microsoft or Google or Amazon. And yes, you can do serverless in-house, but it's not really serverless because you're still doing it on-premise and have all the problems with that. And so you can focus on writing code that provides business value. Like this is the whole point here. We want to put as much of everything else away so we can focus on writing code that brings value to our business or to our non-profit, whatever, value. So usually you see this like graph, like what do you have to stop thinking about as you move from on-premise to software as a service, which is an example of that is maybe Auth0, which has solved the problem, or Azure B2C. They've solved the problem like of authentication and authorization, so you pay them to give you that service, and you don't have to worry about it. You can provide value by writing business code. So as you move from on-premise to infrastructure as a service, you stop thinking about power, you stop thinking about cooling, you stop thinking about the toilet the security guy at the data warehouse have and use while he's there. And as you move from infrastructure as a service over to platform as a service, you stop thinking about networking and firewalls and all this stuff. And if you reach platform as a service and are doing it now, then you're doing pretty good. Then you have a lot of worries thrown out the door, but you still have to think about a few things related to uptime and scaling. And I've taken this quote from Martin Fowler's blog, where there's a very good resource on serverless if you want to know more. And this is a good quote. If your platform as a service can efficiently start instances in 20 milliseconds that run for half a second, then call it serverless. That's like the point here. You actually pay for what you use. So if you're running serverless, then in the middle of the night, nobody is trying to reach your app, then you're at zero. You scale your node down to, or you don't do it. It's just zero. Nothing is running because there are no requests or input to handle. Where you usually would, in a platform as a service world, have an app running ready to receive a request. And if it suddenly comes 1,000 requests, it has to, you usually have auto scaling or something like that. It starts scaling up. But with serverless, if 1,000 requests comes in the middle of the night, then 1,000 requests are processed in parallel because they start up, they run, and they quit. Do their job. So you can look away from this scaling issue, and the thing I'm coming back to all the time, which is like the main point, is write code that actually is useful to you. Of course, you should be careful with serverless that you are not running a denial of service attack on your wallet, because it will scale unlimited. I actually read a blog post a few days ago about a guy who put up 2 Azure functions that were calling each other through queues, but every time they called each other, I think he doubled the number of requests. So it's just getting more and more and more and more. He just had to stop it in the end because he lost all his Azure credits or something. But just be aware of this. And also, I just want to note that this is like serverless or functions as a service is not a silver bullet. Of course, as with everything, there are some things to think about. As I said, you scale to 0, so something has to start when your request hits your app. which means you have some kind of latency where a platform as a service application could be ready and primed, cache running, everything, and when a request hit, it's like, boom! With function as a service, they're all the time working to get the latency down, but there is something that has to get injected and started for your request to be processed. So there is kind of like a startup cost every time you start it. And of course, since it gets stopped after it's done, you have to think about state in these functions. If you want to have some kind of state, it needs to be pulled from somewhere, some kind of document DB. You have to run it through your state machine and then save it again because the function doesn't have any state. Also, running these things locally on your own machine is a bit of the more you like put the things in the cloud, the harder it gets to get a short feedback loop running on your machine. You have to have a dev environment at your cloud provider, and you're working against that all the time. Does something with your feedback loop where you, with a normal little program, can be on your machine and everything happens there. And of course, vendor lock-in is a problem with serverless. If you start using these services, of course, you should write your code as you always do it, with good modulation and libraries and everything, but you will most likely start using services that, and should probably in most cases, but just be aware of it if it's very important to you that you can change or switch your provider at any time. So we're going to go to Azure Functions, not because the code we're making or made doesn't run in any other cloud provider, but because Azure Function supported F# straight out the door, and we already had Azure subscription. So I'm not going to be here telling you Azure Functions is the best function as a service platform. I'm not sure I think that myself. It's just suited our needs the best, and we already had Azure subscription, so, and it works. The cool thing about Azure Functions is that the runtime is running on top of app services, which means that all the things you get from app services that you love and hate, you get them in Azure Functions too. Things like deployment slots, authentication in front of your function. You get this whole dashboard you're used to. And also a cool thing is that the runtime of Azure Function can run locally on your machine. So you can run up your functions on your machine and debug through them, set breakpoints and everything. As far as I know, no other cloud provider offers that with their serverless offerings. And of course, you have a lot of triggers and integration to services already in Azure, which I will show a bit later. The bad thing with this runtime is, of course, it only runs in Windows, and I prefer to use OS X, so I don't get too much gain out of that. I guess they will make it cross-platform, like everything else they're doing now, Microsoft, but right now I can't use it on OS X. That sucks a bit. Okay. So now we have the two tools we want to use. We want to combine F# with Azure Functions to solve our problem, to find the changes between these environments. Let's get out of the slides and actually show something. So the code base looks something like what you can see on the left here. It's a normal solution that you would make in Visual Studio or anything. Has this is how I would make any .NET solution these days. But what's important here, if you look away from the names here, like, oh, function, this is interesting, suave. Like, the main thing here lies in a library, because even if I'm going serverless, I'm still going to write my business code, I'm still going to write modules, I'm going to put it in libraries. I'm not going to change my good habits of doing that just because I'm suddenly running functions in the cloud. So this is a very simple library where we basically have one entry point. And it's a function to get changes between environments. Just what we wanted. It takes in some arguments, and those include some input, which we saw earlier, the input. It also takes some things it needs to know in our specific case for finding this out. And if I was coming here showing you best practices, this would probably be lying in a key vault on Azure or some more secure place. But right now they are in an environment string. So don't do that if you're in, if you have sensitive information or something. It's not best practice. But anyway, this is our input to the function. And I just want to be very clear that what I'm about to show you with the type providers and everything, even though you see Jira and TC for Team City here, that's not really relevant. That's just like an implementation detail that we use those systems. It doesn't mean you have to. So we take in these arguments, and here we see the first sign of a type provider, because we actually have a config that gives us some more information. It actually holds the URLs, it holds the link to GitHub so we can hook up commits and have clickable links in our changelog. It also gives us the mapping between Octopus Deploy and Team City, so we know which Team City build configuration is related to what Octopus project. Again, this is just implementation details. It doesn't really matter. It's just for mapping between the systems. Small and easy. But the cool thing here is that I'm using the YAML config type provider from F# configuration, and I'm reading in this YAML file, and it creates a type for me. And as you can see here from the signature, I get the things I provided in the config as types, as strongly typed. I get them strongly typed. And you can see here that it even discovered that these URLs are URIs. It doesn't give me strings. It actually gives me URIs. And it creates another type inside my projects because it saw, okay, you have a list of something in your config. So now I can pull out these values that I want from there, and I have what I need to start fetching the two things I was wondering about. Which version is in environment X, which version is in environment Y. And these are, of course, the same function is called, but just 2 times, 1 time for each environment, X and Y. So inside here, this is just implementation details, basically. But what we do, we have to put like the API key in the header. And then we have to call the projects list to get the list of projects so we can get the project ID. You get my point. This isn't relevant for this. This is because the way the API of Octopus is built up, I have to do a bit more calls than I would actually like to. But the cool thing here is, again, type providers. This time I'm using the JSON type provider, and I've provided samples for these 2 endpoints I'm calling. One is the project list, which is an endpoint, and this is what I do. I just call it from Postman. I get the response, and I paste it in here as a string. When I put literal over, it's just it's the same as a constant in C#. What it means is that I now have a sample here that my type provider can read and make types from. So it doesn't have to be polling the API that provides me this JSON in any way to create the types, because I don't want that. So in this case, where I pull JSON over the net, I want a sample here to create my types from. When we use the SQL type provider, we have like we did in the other project that I showed you earlier, then we actually have a local DB running on our own machine with the latest and greatest migration, and it checks constantly that what you're writing maps the schema. So I basically read in these two samples, and what what the type provider does, the JSON type provider, is to make me types. So when I then go on and do a HTTP request and get this project list JSON back from the API, I can parse it with my type, and then I have type safety here, and I can map it over to the items, and then I can go in and I can see, okay, which project in the list has a name equal the project name that was the input to my function. And I give I just crash everything if I can't find it. Of course, you can do whatever you want here. Then I have the project ID. Then I can do another API call to get all the information about the project. And in there, I can find out which version of the app is actually deployed in the environment that I'm interested in. So a bit of back and forth, but I get type safety the whole way, so I'm not really scared. And if there's something with the JSON response that is not parsable in any way, I can still kind of access the properties unsafe. This is a bit, the reason for this is that the Octopus API puts things like IDs here, not inside some kind of value, but in the JSON as an object. So this ID, I don't know what it is, or I need to parse the deployments to find it. So anyway, a lot of just working with the Octopus API, but type safety, and it all fits here on a pretty zoomed in screen. So that's cool. And in the end, it returns the version of the release. So basically, super simple function, takes in these 4 things, puts out a version name. Then you can see that we do the same for the 2 environment version, and then we have the 2 versions that we want to find the differences between. What we do then is read from the config file again, where we had all the projects. So you can see here we have a list of projects. We now have the Octopus deploy name because that's our input. That's how we reference to the project name. And now we want to go to Team City to find a difference between the 2 versions we just pulled from Octopus. So basically, this is just code for mapping from the Octopus name to the Team City name. And then we have another function which basically does the exact same thing as the first function, just towards the Team City API. Some specific things here that are not important, some troubles with the Team City API we have to handle a bit. It's not really important, it's probably a nicer way to solve it. But basically what we do is call the Team City API, and we ask for one build, and we want everything that's happened since another build, and we are interested in things like the number or version, the status of the build, but especially this is what we're here for, changes. And we want the ID and the comment. We only care about the comment because remember from before, that's what we're going to parse. So we parse in, we get the changes and we get them type safe with the type provider. Not too much code. It's more like just handling the data. And we end up with, the builds in a, and what you see here that we have a sequence. Sequence in F# is the same as an enumerable of build. Because what we do inside here is that in the end, we actually map them to our own type of build. Because we want to just put them in a type for easier work with them later. So then we have the builds, and then we can just start. Here's some hard coding, by the way, but we have this info here in the config, so this should probably read from the config and not do this horrible hard-coded matching here. But basically, we just go through all the commit messages, regex them, find the Jira keys, and then The same thing again. I don't even have to go into this one because you know what happens. Takes some input, uses the type provider and a sample from the Jira API to get type-safe access to the Jira API, and it gets the things I am interested about in these issues. So we parse them, and we do this thing that we mentioned earlier. We parse the merge commits from because we pull the changes from TeamCity, and that's all the changes. So we want to find what are the merge commits, because we want to show the merge commits in the bottom of our changelog for developers. We check if there is the hashtag DB migration. And even if you don't know F# and this looks like a lot, it's super simple what we're doing here. Just doing some regex testing to filter on that, and we're just checking if something has this DB migration tag. And then when we have everything we need, we can create our changelog type. And that's what we return from this module. We get the project name, we get an environment that this changelog is from, which includes the name and the version. We have two, same there, name and version. We have all the commits in between these two versions, or all the merge commits. We have all the Jira issues mentioned by our developers in the PR title, which becomes the merge commit. And we have info if there is a migration or not. So that's basically the library that lets us create the changelog. And now it doesn't matter where I host this. Like this was a module or a project that solves a specific problem. And I made it this way, so now if I want to test it, I want to run it up, I can use Suave or anything else. I don't have to use Azure Functions. So basically, just put in the parameters here, hard-coded. I map up some few endpoints just to test, and I added like just a small module to take the JSON and turn it into something that is readable. So now if I build it, we'll hopefully be able to find, actually don't build in parallel here, so it's my fault that it's taking some time. Now we built Suave, and I just want to run it up here to Mono. And I see it's running on 8080. So if I now go to 8080, basically all it should do is get changes as Markdown. It calls my library that we looked at before, and it takes this changelog type and turns it into something that's readable to me. Basically, it turns it into Markdown because that's easier for me to write, and then just uses a library that takes Markdown and makes it into HTML. So if I now go to localhost 8080. Now I'm betting everything on, yeah, there we go. Now I checked actually between the dev environment and production. So as you can see, there is a lot of stuff here. But the cool thing is that we have now links straight into Jira, where we can check out these tasks. That was very poorly formatted. And we can see what kind of, is it a task, is it a bug, what is the status in our Kanban board, is it under peer review, is it done, so what's the story, and we see all the merge commits, and this package changes the SQL schema and possibly data. The reason why we're wondering if there is a DB migration is because we do rolling deploys, and if someone does a breaking change, we don't want people to do breaking changes in the database over just two versions, but if somebody does, during our rolling deploy, we will have two versions in production until the new version is all the way, have replaced the old one. And if we have two versions that don't work against the same database, then one of the versions will crash. So when we do a breaking change in the database, we want to do it over three versions. So first we make a version that implements the change, but in a way that also works with the old version. And then when we got that version out and the old one is gone, then we can make a new version that actually maybe deletes or does the breaking change towards that version before. So you need to have kind of a middle version to fix that, which you don't need if you have like a more appropriate data store or blue-green deploys or something like that. So now we have something that they can use and they can test with to see if the changes going to production work. We have it running. Here it is from between QA and production right now for one of our systems. Piling up because everyone is at NDC. And we put this like as a minimum viable version of it. We just put it in Azure Functions as one function, which looks like this. Basically what we do is that this is a function that takes a HTTP request and returns a HTTP response. Can't get more easy than that. And this is the one of two files you need to do that. Here you basically, we just in an ugly way parse out from the HTTP URL get parameters what these parameters we need are, and we have one extra that says like, okay, I can give it to you in JSON, or I can do this ugly thing we have here, like if you pass false to the JSON parameters, it gives you a markdown. This was like the first thing we just write down to get it out, and it worked. So this is now hosted in an Azure Function app. This is the Function app UI. It's a bit different than some of the other UIs on Azure, but if you go to Platform Services, you'll see what I mentioned before, that Azure Functions has a lot of the same stuff that App Service has, because it's built on top of App Service. So here's our function, and I can't see my function here. All I see here is the function.json file that you put next to your function. It tells something about what Azure Function should expect in and out of your function. So here you can see what triggers the function. Yeah, it's a HTTP. And it only works with GET, and it responds with HTTP. But what you should notice here is that the reason I can't see the code is because before we deployed it, we compiled it to get compiler feedback. So basically we're saying we have a DLL which has a namespace with this run function I showed you just now, and run that. So I can't do too much here, and you see here it says your app is currently in read-only mode because you have source control integration enabled. So it's a lot of power in this tool they have here. You can create new functions and work with them, but they are, we noticed quickly that we don't like working with Azure Functions in the UI here. We want to do compiled functions and that we know will work when we put them up here, because if I put a script file up here, it might run fine. I change one line and suddenly it gives me a lot of errors, like that I can't even fathom what they are about. So that's kind of my problem with Azure Functions right now, is that they're moving very fast to implement everything they need to implement, and I feel it's not really there in stability. I'm hoping to catch some tricks tomorrow in Matthias' talks, where he's talking about F# functions too, and how to scale it. But basically what our conclusion is that we only wanted to put compiled version of the functions on Azure Functions, because if you put a script file like CSX or FSX file, it will compile it on in your app, and you might get errors that are completely different from when you do it on your build server. So basically what is in this function, all we have here is just a function.json. We have our changelog.provider, which is the library that we looked at before, and we have the Azure Functions function itself as a DLL that we are bootstrapping in here. And we have some dependencies that we just included here. That's another thing with Azure Functions, is that it includes a lot of dependencies for you automatically. So like newtonsoft.json is just there. F# is just there, F# core. And a lot of other things are just magically there. So when you try to work with it on your local machine, it's pain, because suddenly you pull a sample and you put it into your editor and you want to work with it, and it's just red squiggly lines everywhere, because there are some dependencies that are just there magically. Oh God, I hate that. But it's easy to get started, and like many things I feel Microsoft do, is always easy to get started. And, going further on, it's usually a bit more difficult. Another way of looking at this application would be something like this. Now we're looking at 3 functions and a lot more complicated architecture to solve a simple problem, if you'd say. Now we're suddenly in a resource group where we have some storage. You need storage for your function app anyway, but we're using it in our functions. We have a Cosmos DB, which is where we basically just use the document DB to save the JSON. And I also tested and it works using service bus, but in this solution, we basically use the queue of the, because storage accounts can have blobs, files, tables, and queues. I would never use these queues with if I have a high latency, if I have a high throughput system that I'm trying to make serverless, I would never use these queues. I would use Azure Service Bus. So what we got here is basically, actually we can look at it in the editor, it's easier. We have one function that basically does nothing other than take in a HTTP, trigger on an HTTP request and put something on the queue and then return. The reason for this is that we're contacting 3 different systems. So I don't want people or systems calling for changelog generation to have to wait for it to contact 3 systems and generate the changelog. I just want it to come out in the other end somehow. So this one just puts it on a queue and returns and says, you're good. So basically, as you see here, we just check the variables and we pass them on to a queue. Then we have another function which we call the generator function, which basically triggers on something coming onto that queue and outputs into document DB, because we want to store the changelog for historical reasons. But it also has another output which puts it in another queue called send mail. And we have a third function that listens, has a queue trigger in, so it triggers when something comes on this send mail queue, and it reads in from document DB, which is included in the message, which document ID we should pull out, and it uses the SendGrid integration that Microsoft has. SendGrid is a software as a service email for email sending. So we can use the output here to send an email. And then basically we create this same markdown-ish HTML that we made before, but it goes through this whole super over-engineered solution to send out an email to an email group that cares about these things in the other end. So this is like a way to do this. And here you see I'm using scripts and everything, but you can see here, to get things to work on my machine, I have to download the Azure Function tools from NPM. I have to start pulling DLLs in to make sure that I have all the dependency needed. And I think I saw a blog post from Matthias, so I think he's addressing this a bit on how to work with it tomorrow. So that's another solution which feels a bit more serverless, but at the same time, since I'm working on OS X, I don't have compiled functions, so this is hard to work with. As you see here, there's something I don't have. There's a DLL I haven't included that has this, which magically is there on Azure Functions. So if you're going to work with Azure Functions right now and do something complicated, I would probably use Windows, Visual Studio, and Azure Functions Runtime. And it hurts to say that, so I hope they really work on these things. Yes. So that was like basically my conclusion. So I'm pretty sure nobody's going to run out of this room now super eager to start using Azure Functions in production. But I think you maybe saw some cool use cases for it, and to start using it like we've done in our project with like the small things, and then you can build upon that. At least the second architecture that you saw, where we put it in the document DB, then you can build on that and like make pipelines that diverge and solves different problems, but it's a more of a scalable architecture or expandable architecture. So it feels a bit wobbly to work with for me, who's not on Windows and in Visual Studio. I hope you are feeling that F# is the thing you're going to look at next time you're going to integrate with other systems or read from any kind of data source, because F# type providers will save you a lot of time doing that. If you're a bit smart about it, you can easily do it from a C# solution like we are doing. It's worth it. I also want to say that the F#, or the functional, not F#, I'm sorry, functional programming lab hour. There's going to be Elm people there if you want to look into Elm, and probably Elixir people, because it was just an Elixir talk, and it's out above the entrance, and all of the speakers are going to be there to answer your question. If any of you have any questions to what we looked at in this session, just come there, talk to me. For those of you who are from Oslo, make sure to follow NNUG, the .NET user group in Oslo, which also has the also F# meetup. And thank you. That's it.